Alright, so these are the class notes for 10.5. We are going to be solving by completing the square. What that means is that if we have a polynomial and it's not factorable on its own, we can use this method called completing the square in order to create a polynomial that we are going to see that it will factor perfectly. So, in order to complete the square, you need to have the form x squared plus bx plus blank, and in that blank you add b over 2 squared. So into our blank we add that b over 2 squared, and that b comes from our middle term. So let's try this. Example 1, we have x squared plus 8x plus blank. It already is in the proper form. We have plus blank, so into that blank we have to add b over 2 squared. Our b, in this case, is 8. We have 8x. So we're going to plug in 8 for b. We get 8 over 2 in parentheses squared. 8 over 2 is 4. And 4 squared is 16. So we plug 16 into the blank. b, r squared minus 18r plus blank. Into that blank we're going to add in b over 2 squared, where our b is negative 18r. So we have negative 18 over 2 squared, which reduces to negative 9 squared. But the negative is still inside the parentheses, so I squared the negative. So negative 9 times negative 9 is a positive 81. In part C, I have k squared minus 7k plus blank. So my b is minus 7. So I take minus 7 over 2 in parentheses squared. Now, 7 over 2 doesn't reduce nicely. But remember, in your rules for exponents, if you're squaring a fraction, you can square the top and the bottom separately. So I have negative 7 squared over 2 squared. Negative 7 squared is 49. 2 squared is 4. So into my blank, I will add in 49 over 4. Alright, so next step. Again, we will be filling in the missing factor to complete the square. But then we're going to factor the trinomial and see what happens. So, what are we going to plug into the blank on A? X squared plus 10x plus blank. Our B is 10. 10 over 2 squared. 10 over 2 is 5, and 5 squared is 25, so I add 25. Now, I want to factor this into my two binomials. So, in the first term in each has to be x. When I multiply, I get x squared. The second term in each has to multiply to give me 25 and add up to 10. The only things I know that multiply to 25 other than 1 and 25 are 5. So, I'm going to take x plus 5 and x plus 5. Part B, I have r squared minus 6r. So, to complete the square, I need to add in negative 6r over 2 squared, which is negative 6 over 2 is negative 3 squared, which gives me a positive 9 that I add. So when I factor this polynomial into parentheses, I will have r and r in each, and then I will have r minus 3 and minus 3. They multiply to give me 9, and when I add them, my middle term, I'll have minus 3r and minus 3r, which gives me, in fact, minus 6r. Last one, k squared minus 3k plus blank. In that blank, I have to do b over 2 squared, so minus 3 over 2 squared. Again, I can square the top and bottom separately of my fraction, so I have negative 3 squared is 9 over 2 squared, which is 4. This one's a little bit more difficult to factor, but go ahead and write your parentheses. The first term in each is going to be a k, so I get k squared. But what multiplies together to give me 9 over 4? I will give you a hint. Look at what you already squared to get 9 over 4. Negative 3 over 2. So we know negative 3 over 2 times negative 3 over 2 gives us 9 over 4. So let's try plugging that in. Will that work to give us our middle term of negative 3k? Let's see. If I multiply this and the insides, I have minus 3 over 2k, and the outsides also give me minus 3 over 2k. So if I add those together, minus 3 over 2 plus minus 3 over 2 gives me, I can add just the top since I have a common denominator. I get negative 6 over 2, which reduces to negative 3. So I'll have negative 3k as my middle term. So it works out. Now, what do you notice about each of these polynomials when factored? Here we have x plus 5 times x plus 5. Those are the same. If they're the same, if we're multiplying something by itself, that's the same thing as squaring it. So we can rewrite this as x plus 5 squared. Again, in b, we have r minus 3 and r minus 3. We can write that as r minus 3 squared. And our last one we can write as k minus 3 over 2 squared. If we complete the square, when we factor it, we should always get a polynomial that we can rewrite as being squared. Checkpoint. Pause this, try it on your own, then unpause and see how you did. Fill in the missing factor, and then factor the trinomial. Alrighty, so check and see how you did. The last one was a little bit trickier, but since I do 5 over 2 squared to get 25 over 4 is my third term here, I know 5 over 2 times 5 over 2 will give me 25 over 4. So that's how I got this inside of my factor. Alright, next page. When would you use completing the square? That is whenever you are solving for a variable and when the trinomial doesn't factor on its own. So I could say when the trinomial, or a polynomial with 3 terms, is not factorable. Now, more importantly is the second question. What form should the equation be in? In order to complete the square, you must have it first in the form x squared plus bx plus blank. You cannot have another number here. If you're dealing with an equation, it can be equal to some number, but if you add b over 2 squared to the left side, you also must add it to the right side. So I like to put a plus blank on both sides of my equation. Your equation must be in this form before you can complete the square by adding b over 2 squared. Let's try it. Number 1. Pretend that this is a y and not an x. We have y squared minus 8y plus 12 equals 0. I need to get it in the proper form, and so I need to get rid of this plus 12. That means I'm going to subtract 12 from both sides. So I have y squared minus 8y plus blank now equals negative 12 plus blank. I need to add in b over 2 squared into both of these blanks. My b is negative 8, so negative 8 over 2 squared, that's equal to negative 4 squared, which is 16. So I add 16 to both sides. Okay, now I'm ready to factor the left side of the equation. So what goes in here to factor it? I know my first term is going to be a y, and my second term has to multiply to give me 16 and add up to minus 8, so I'm going to use minus 4. I could write this as y minus 4 times y minus 4, but we know that that is the same thing as y minus 4 squared, so I'm going to write it like this. And that is equal to negative 12 plus 16, which is 4. Now, think back to 10.4. If I have something squared and it's all by itself, I can take the square root of it. So we're going to take the square root of both sides to get rid of that square. The square root of something squares undoes it, so I'm just left with what's in parentheses, y minus 4. And that is going to be equal to the square root of 4, which we know could be positive or negative 2. So I still want to solve for y. I haven't quite gotten y by itself. But since this equation could equal plus or minus 2, I have to set up two equations. Y minus 4 equals positive 2, and y minus 4 equals negative 2. I can solve each one separately. On the left, y minus 4 equals 2. I add 4 to both sides and get y equals 2 plus 4 is 6. On the right, again I add 4 to both sides and get y equals negative 2 plus 4, which is 2. Alright, let's look at example 2. X squared plus 6x minus 7 equals 0. Add 7 to both sides and get x squared plus 6x plus blank, which is the proper form, equals 7, also plus blank. To fill in that blank, I need to have b squared, so 6 over 2 squared. 6 over 2 is 3, 3 squared is 9. I add 9 to both sides. Now I need to factor my left side of the equation. This will factor into x plus 3 squared. 3 times 3 gives me 9. 3x plus 3x gives me 6x. And that will be equal to 7 plus 9, which is 16. Now I need to square root both sides. When I square root the left, square root and the square undo each other. I'm just left with what's in parentheses, x plus 3. That will be equal to the square root of 16, which is plus or minus 4. Set up my two equations. X plus 3 equals positive 4. X plus 3 equals negative 4. Subtract 3 from both sides, and x equals 1. Or, if I subtract 3 from both sides over here, x equals negative 7. Have my two solutions for the problem. All right, we are just going to try one more, number 3. Number 3, you notice we have 3m squared plus 30m equals 12. We have a plus blank here. However, we cannot have a coefficient or a number in front of our first term that's squared. We want to get rid of it, which means we have to divide out a 3. However, if we divide a 3 out of this term, we have to divide out of everything in the equation. So, we're basically taking out a GCF of 3. So when I take a 3 out, my first term will just be m squared plus 30 over 3 gives me 10m plus our blank equals 12 over 3, which is 4, plus blank. Now what do I add into the blank? My b here is 10, so 10 over 2 squared is 5 squared, which is 25. Add that to both sides. And now I need to factor the left side, so I have m plus 5 times 5 gives me 25. 5 plus 5 gives me 10. So that will work as my factoring. M plus 5 squared equals 4 plus 25 is 29. Now I'm ready to square root both sides. And I get m plus 5 equals, and this is going to be plus or minus the square root of 29, which is a decimal. But I'm going to leave it like that for now and just put it into my calculator at the very end. So I'll have as my two equations, m plus 5 equals positive square root of 29, and m plus 5 equals negative square root of 29. Both times I need to subtract 5 from both sides. So I can plug into my calculator, m plus 5, or m equals square root of 29 minus 5. And on the left, if I subtract 5 from both sides, m equals negative square root of 29 minus 5. Now try plugging those into your calculators and make sure you are plugging it incorrectly. When you plug in the square root of 29 and then outside of the root minus 5, you should get 0.385. When you plug in negative square root of 29, the negative is outside the square root, and then minus 5, you should get negative 10.385. So make sure you know how to plug these into your calculator correctly.